Welcome to another wonderful edition of Comet Algebra. This video is for Algebra 1, Chapter 11, Section 4, Dividing with Radicals. So first we'll talk about what's called the quotient property, meaning when two numbers are under the same radical and they're dividing them, you can split them up into two separate radical signs and they can be under the same radical sign. And we want to be able to move this way to break them up into different radicals when we need to, or move this way when we can divide them and they're easier to simplify. So this is just a property we need to learn both ways. And please note this, we use this property when x is 0 or positive, and we use this property when y is positive, and of course y cannot be 0 because we can't divide by 0 in our number system. So I'm going to do number 1 and illustrate the property at the same time. You won't always write out all these steps, but I'm going to for our first examples, and they're nice to have in your notes. So square root 40 divided by square root 5 can be written like this: square root 40 divided by square root 5. And then according to the quotient property, I notice that they are divisible. This does work. So we're going to put them under the same radical sign so that it's very easy for us to see I can go ahead and divide 40 by 5 and get square root 8. And of course, square root 8 has a 4 in it, 4 times 2. I'll just write that up here if you want to see that. The square root of 4 is 2, so that's what comes out in front. So the simplified answer is 2 square root 2. All right, example 12 is already written in the fraction format with square root 15 divided by square root 12. So using the quotient property, I can write those under one radical sign because I'm seeing there's some work I can do here. 15/12 does reduce. So let's reduce that by 3 and see what we have to work with here. So now this is interesting, which leads us into our next discussion. A radical fraction is not considered simplified if you have a square root or any root in the denominator, because it's not, we can't divide by an irrational number. We want to avoid that. So when I split this one up, I have square root 5 over square root 4. And this makes us very happy to see. When we have a perfect square in the denominator, our work is done. This is completely simplified because the square root of 4 is 2. There's no perfect squares left to take out of the 5, and my denominator does not have a radical in it. So example 2, that is the simplified answer. So you may ask the question, well, what do I do if I end up with the square root in the denominator? Well, we're going to have to learn a process to take care of that. Like I said, fractions with radicals are not simplified because you would be dividing by an irrational number. Remember, any square that isn't a perfect square is irrational. So the process we're going to learn is called rationalizing the denominator. Very, very important. During this process, we take our fraction and we have to come up with a multiplier that's equal to 1. And the multiplier has to be chosen carefully so that it changes our denominator and gets rid of the radical sign. So some examples of ways to multiply something times 1. Well, would you agree that 5/5 is 1? Okay, so you could multiply something by 5/5 and you haven't changed it. Or would you say the square root of 3 over the square root of 3? That's also equal to 1. So there's many different ways to write 1, and we're going to choose the one that's helpful to us to accomplish the goal of rationalizing the denominator. So let's take a look at this process. Now example 3 is not simplified because we have a problem. We have a square root in the denominator, and we cannot divide by that irrational number. So we're going to multiply this fraction times 1, except that didn't change anything. So let's choose a different way to write this 1 that's going to help us. If I want to get rid of this square root sign in the denominator, I could make this a perfect square. And I'm noticing that I have 7. So if you multiplied the square root 7 times itself, you would have the square root of 49, and that's a perfect square. So that's the hint. Whatever this is, we put it over itself, because square root 7 over square root 7 is equal to 1. So I am not changing my original fraction. I'm not changing the value of this. I'm just multiplying it by 1, but I chose this 1, the way I write it, very carefully so that it helps me. So now go ahead and multiply straight across. Square root 5 times square root 7 is square root 35. Square root 7 times square root 7 is square root 49. And ta-da, we made it. We made a perfect square. And that is, square root 49 is 7. So there is the simplified form of our original fraction. And it's simplified because there is not a radical in the denominator. All right, let's look at example 4 now. It is to our advantage to write these in the fraction format. So let's rewrite it as square root 3 over square root 6. And I'm not going to multiply by square root 6 over square root 6 at this point in the problem because I see that I have a 3/6. So I'm going to think of it like this because that reduces to 1/2. And when you can do this and make your life easier, I suggest you do it. Now let's split it out. Do you recognize 1 is a perfect square? So if I split this into square root 1 over square root 2, this is 1 over square root 2. We always forget that 1 is a perfect square, but so I'm almost done. The only issue I have here is that there's a square root in the denominator, so we're going to multiply this fraction by 1, and we're going to write that 1 as square root 2 over square root 2. So then multiplying straight across, 1 times the square root of 2 in the numerator is square root 2. Square root 2 times square root 2 is square root 4, which is 2. And that is my simplified answer. All right, in example 5, I'm noticing right away here in this 75, this can be simplified. There's a perfect square. 75 is 25 times 3. So I'm going to make my life easier, and I'm going to simplify this before I take care of the root in the denominator. So the numerator remains unchanged. Square root of 25 is 5. That's what comes out in front. So now instead of multiplying by the square root of 75 over the square root of 75, all I have to take care of is the square root 3. Now you don't have to do anything with the 5. A 5 is perfectly fine to have in the denominator. So just, keep it. It's cute. Just let it sit there. And then remember, we want to multiply this by 1 so we don't change the value of the fraction. And we write that 1 as square root 3 over square root 3. Go ahead and multiply the numbers that are under the radical. So we have square root 6. And then I have 5. I'll do this in steps so you can see every step because 3 times 3 is 9. The square root of 9 is 3, so I can do that. So I end up with square root 6 over 15. And that is my simplified answer. All right, this last example, you'll notice, is dealing with cube roots. And this is a little more complicated. I'm not going to expect you to master this skill perfectly in Algebra 1, but I do want you to see it and be familiar with it because you will be mastering it in Algebra 2, and I'd like you to have a little prior knowledge to draw from. So let's follow the same steps, but remember we're just dealing with a cube root. And did you notice that 8/16 can be reduced? So it is to our advantage to put it under 1 cube root sign and go ahead and reduce the 8/16 to 1/2. Okay, now let's split it up. Again, cube root of 1 over cube root of 2. And did you notice that the cube root of 1 is a perfect cube? So this becomes 1 over cube root 2. So now this problem doesn't look so bad. Well, what I need to end up with is a perfect cube in my denominator, and right now I just have a 2. So this time the multiplier is a little more thought has to go into choosing the multiplier to end up with what I want. So I'm writing this out in a format. This is what we have. This question mark is what is the multiplier have to be to give us what we want. So let's write what we want here. I want the cube root of a perfect cube. Since 2 is the base here, the base with using the base of 2 with a perfect cube would be 2 to the third. So if you have the cube root of 2 and you want the cube root of 2 cubed, then the question becomes is what does the multiplier have to be? Well, obviously it's the cube root of something. If I have a 2 and I want 2 to the third, the part that I'm missing is 2 squared. So we have to multiply top and bottom by the cube root of 2 squared, which I could write as the cube root of 4. So just stop and think about this for a minute. We have 1, 2, and I want 3 of them, so my multiplier has to give me 2 of them. So now multiply 1 times the cube root of 4 is just the cube root of 4. And the cube root of 2 times the cube root of 2 squared is the cube root of 2 to the third, which is exactly what I wanted. This is a perfect cube, and I can do that. So my final answer becomes the cube root of 4 all over 2. Like I said, we'll work on this together, do a couple more in class, and I think you'll get it. All right, now you have the knowledge you need to do section 4. So have an awesome radical time with that.